It's been discovered that there are a lot of weird and unusual things happening on Jupiter that we didn't know about. The first infrared images from the James Webb Space Telescope were studied, and new structures have been found within Jupiter's iconic Great Red Spot. A storm so massive and powerful its winds move at speeds of 270 to 425 miles per hour. 3.5 times faster than a powerful F4 tornado, and big enough to engulf our entire planet at once. Jupiter's Great Red Spot is a massive storm that's been swirling for centuries. But lately, it's been found that this enormous storm isn't as stable as it once seemed. It's wobbling, almost shaking, and its size has been fluctuating in ways that are pretty surprising. The Great Red Spot is shrinking. It used to stretch over 24,000 miles across, but now it's down to about 10,000 miles. But here's the twist. It's not just steadily getting smaller. The storm has been expanding and contracting, almost like it's breathing, and it's not exactly clear why. The wobbling motion is fascinating. It might have something to do with the wild jet streams and turbulence swirling around it. Jupiter's atmosphere is chaotic, and all that energy could be nudging and pulling the storm in different directions. On top of that, Jupiter generates a ton of internal heat, which could also be affecting how the storm behaves. Not too long ago, there was even a moment where pieces of the storm looked like they were breaking off and drifting away. That had some people wondering if the Great Red Spot was being torn apart. But here's the thing. This storm is powered by an insane amount of energy, so it's not going anywhere anytime soon. It might change shape or size, but it's likely to stick around for decades, maybe even centuries. The Great Red Spot's recent wobbling and size changes are just another reminder of how dynamic and unpredictable Jupiter is. And the new images we're starting to see are uncovering all kinds of mysteries about the gas giant. Citizen scientist Judy Schmidt of Modesto, California, processed these images of Jupiter using data from the James Webb Space Telescope to further enhance the original photos. The results were breathtaking. You can clearly see the auroras and, in another image, a tiny debris ring and a few moons around the gas giant. The clarity of these images has allowed us to study Jupiter's dynamics in ways never before possible. Jupiter's upper atmosphere acts as a boundary between the planet's strong magnetic field and the different layers of atmosphere below. At the poles, the spectacular auroras are fueled by volcanic material ejected from Io, one of Jupiter's moons, which we'll talk a bit more about in a moment. Closer to the equator, the atmosphere is shaped by sunlight. Since Jupiter only receives about 4% of the sunlight that Earth gets, it was long assumed that this region would appear mostly uniform. But in July 2022, Webb's near-infrared spectrograph observed Jupiter using its Advanced Integral Field Unit to study the area above the Great Red Spot. The goal was to see if this region was as uneventful as everyone predicted. Instead, the observations revealed a surprising variety of features. Dark arcs and bright spots spread across the area. The blue areas in the image are at a much lower altitude than the areas in red, showing that this storm has an interesting structure. While sunlight influences the light from this region, it was found that another mechanism may be at play, altering the atmosphere structure. One explanation involves gravity waves, similar to ripples caused by waves crashing on a beach. These waves, which originate deep in Jupiter's turbulent lower atmosphere, travel upwards and shape the structure and emissions of the upper atmosphere. Interestingly, these kinds of waves are occasionally seen on Earth, but are far weaker than what Webb observed on Jupiter. But something else was discovered. A new, never-before-seen feature in Jupiter's atmosphere. The big white band of clouds at the planet's equator that is more than 3,000 miles wide and sits above the planet's main cloud decks was discovered to be moving across the planet at 320 miles per hour. That's way stronger than even the most powerful storms on Earth. But not only is the James Webb Space Telescope getting some amazing images of Jupiter, let's not forget that the Juno probe traveled an astounding 1.7 billion miles and is still carrying out its Jupiter mission to study the planet. On its 66th flyby of the gas giant, it grabbed some new images of the planet and a couple of Jupiter's moons that are simply stunning. Using raw image data that's available online to the public, citizen scientists enhance the contrast of the visible light images to highlight the planet's remarkable range of colors and striking visual complexity, and unveiling the intricate dynamics of Jupiter's stormy atmosphere, vivid and powerful bands, swirling cloud formations, and vortices, such as cyclones and hurricanes, of varying sizes and intensities. In many of these images, you can see a series of small cyclonic storms that seem to be interconnected. In fact, these storms seem to form a kind of atmospheric network, suggesting that Jupiter's atmosphere is far more interconnected and complex than many thought. Jupiter is full of mystery, but the planet also has 79 moons, and the biggest of them is Ganymede, or Jupiter 3. In this Hubble Space Telescope image, you can see just how big this moon is. Ganymede orbits about 666,000 miles away from Jupiter, and it's interesting for many reasons. The Juno probe is still out there studying Jupiter and its moons, and it recently grabbed some new images of Ganymede. It was the first time in 20 years that the moon had been seen again in photos, and something surprising was found this time. Images were looked over and evidence was found showing Jupiter's big moon may have been hit by an asteroid nearly 93 miles wide about 4 billion years ago. That's a huge space rock, some 10 to 15 times larger than the Chicxulub meteor that hit Earth 66 million years ago. The impact of this mega asteroid was so powerful that it knocked Ganymede off its axis and altered its rotation. One interesting thing discovered was that most of the material ejected from the collision fell back into the crater, leaving it mostly hidden. Despite this, the evidence for this massive impact can be seen in the moon's surface. Ganymede is actually full of craters, and some of them are very large, showing that this moon has been hit by more than just one massive ancient asteroid in its past. But Ganymede could possibly be hiding something else, and maybe a whole lot more. Just recently, it was discovered that there is water vapor in the thin atmosphere of Ganymede. Located 500 million miles from the Sun, the water ice on its surface is frozen solid in frigid temperatures as low as -300 degrees Fahrenheit. This makes the icy surface of the Moon as hard as rock, but a rain of charged particles from the Sun is still enough to turn the ice into water vapor on Ganymede. And while it may look like any ordinary barren ice ball moon, some believe that beneath the icy crust lies a vast ocean of liquid water. If so, this ocean could be home to life, or it could give us some clues about the conditions necessary for life to emerge. New missions are planned to find out what's down there. Another of Jupiter's incredibly fascinating moons is Io. And this moon does a lot more than just quietly orbit the planet. And this brings us to auroras. Here on Earth, the auroras we see are totally different from those on Jupiter, since they're caused by charged particles from the Sun hitting the Earth's atmosphere. But since Jupiter is much farther from the Sun, no one understood what was powering this planet's auroras. Juno did a flyby around both of the planet's poles, and the probe's instruments detected electrons in Jupiter's atmosphere being propelled toward the planet with energies as high as 400,000 electron volts, an astonishing 30 times more powerful than the strongest auroral potentials recorded on Earth. This time-lapse image also captures a unique phenomenon: emissions linked to the magnetic footprints of 3 of Jupiter's largest moons. These footprints trace the path of Jupiter's magnetic field from each moon down to the planet's surface. These glowing emissions are created by electric currents generated by the moons, which travel along Jupiter's magnetic field and interact with its upper atmosphere. This is important to know, and you'll see why in a minute. Io is covered by lava lakes and more than 400 active volcanoes, which constantly spew out volcanic material into Jupiter's magnetosphere. This Juno probe captured 2 plumes from active volcanoes on the Moon in this image, and just recently, in new Juno data, a huge volcano was seen erupting. Along with all the new image data and combining data from the Juno probe's instruments, it was found that every 27 minutes, Jupiter produces a burst of X-rays. Now it was only a matter of looking at the Juno data to see what other things were also happening every 27 minutes. And this is what was found. When Jupiter rotates, it drags around its magnetic field, which is then struck directly by particles of solar wind and compressed. This compression heats the electrically charged atoms called ions that are trapped in Jupiter's magnetic field. This triggers a phenomenon called electromagnetic ion cyclotron waves. Guided by Jupiter's magnetic field, the ions surf the EMIC wave and eventually slam into the planet's poles, triggering those incredible X-ray auroras we see in images. But that's not the only thing powering these auroras. Io's orbit is 262,000 miles from Jupiter. It cuts across the planet's powerful magnetic lines of force, which turns itself into an electric generator that can develop 400,000 volts across itself and create an electric current of 3 million amperes. And of course, this current takes the path of least resistance along Jupiter's magnetic field lines to the planet's surface, creating lightning and auroras in Jupiter's upper atmosphere. Decades of extensive studies have demonstrated just how remarkably intricate Jupiter is. Just recently, 12 more moons orbiting the gas giant have been discovered. The total number of satellites around Jupiter is now 92, more than any other planet in the solar system. The latest moons discovered have sizes ranging from 1 to 3.2 kilometers. A majority of these moons have extensive orbits, with 9 out of 12 taking over 550 days to complete one revolution around the planet. Scientists believe that because these distant moons move in the opposite direction of Jupiter's rotation, they could be captured asteroids. It's been widely believed that Jupiter acts as a protective shield, safeguarding our planet from threats from outer space. In the past, astronomers have even suggested that this was one of the reasons life got a chance at evolving on Earth. But recent findings cast doubt on Jupiter's role as Earth's celestial guardian. Long-period comets, which originate from the distant regions of the solar system and take millennia to orbit the Sun, typically enter our vicinity. However, thanks to Jupiter's gravitational influence, most of these swiftly moving icy objects are flung away from the solar system before approaching Earth. So the chances of long-period comets colliding with our planet are extremely rare, occurring over millions or even tens of millions of years, and Jupiter's presence plays a crucial role in shielding Earth from these potential impacts. However, the gas giant's gravitational forces have both positive and negative implications for life on Earth. On one hand, its immense gravity prevents nearby space rocks from accumulating and forming into a planet. This led to the formation of the asteroid belt, a collection of numerous small debris fragments scattered between Mars and Jupiter. But nowadays, the gas giant's gravitational pull continues to influence asteroids, causing some to deviate towards the Sun. This change in their trajectory increases the odds of collisions with Earth, and we've already witnessed it in the past. In 1770, Lexell's comet passed just about 1 million miles away from our planet, an extraordinary proximity on an astronomical scale. Scientists believe that this comet had initially come from the outer reaches of the solar system and had a close encounter with Jupiter that redirected its path towards Earth. After completing 2 orbits around the Sun, the comet returned to a point of close proximity to Jupiter 9 years later, which subsequently ejected it from our solar system. The Jupiter shield theory, supported by previous computer simulations, suggested that the gas giant ejects countless long-period comets out of the solar system. And this theory even predicted the comet Shoemaker-Levy 9 striking the fifth planet in 1994. But computing resources weren't as powerful as they are nowadays, and scientists had to make a lot of calculations. Today, we have data that includes a greater number of short-period comets and near-Earth asteroids that intersect with Earth's orbit compared to long-period comets, and new simulations demonstrate a different picture. Jupiter's influential gravity interacts with the asteroid belt, causing gravitational resonances that clear out rogue asteroids and redirect them inward. Collisions between asteroids can also contribute to this process by dispersing rocky fragments into resonant zones. The inner edge of the asteroid belt is particularly affected by a phenomenon known as secular resonance, which drives material into the inner solar system. Jupiter's current mass allows it to both redirect comets towards Earth, as seen with Lexell's comet, and effectively remove them from the solar system. If Jupiter had only 1/5 of its current mass, it would still destabilize comets, but lose the ability to remove many of them, leading to a higher impact rate on Earth. The frequency of impacts plays a crucial role in the long-term evolution of life on a planet. Earth's geological record indicates that an impact rate of one major collision every 100 million years provides enough time for the biosphere to recover and thrive. However, a higher impact rate, occurring every few million years, could devastate the planet, hindering the development of a new biosphere. Some scientists believe collisions with Earth is also how water was brought here. But what about water on Jupiter? Water vapor was first detected on Jupiter in 1995. This discovery was made by the Galileo spacecraft, which conducted extensive observations and measurements of the planet and its moons. The onboard instruments of the Galileo spacecraft, particularly the near-infrared mapping spectrometer, detected the presence of water vapor in the planet's atmosphere during its close flyby. But recent data demonstrates water makes up approximately 0.25% of Jupiter's atmosphere above the planet's equator. While this may not sound like a lot, it's actually an immense amount of water. Jupiter, probably the first planet to form in our solar system, contains a significant amount of gas and dust that didn't become part of the Sun. Knowing just how much water is locked up in Jupiter is crucial for scientists studying the formation of the solar system. In recent years, a team of researchers used telescope data to discover a substantial presence of water within Jupiter's famous Great Red Spot. Launched by NASA in 2012, the Juno spacecraft currently orbits the gas giant, taking close-up pictures of its clouds. Equipped with advanced instruments, the spacecraft has now revealed even more evidence of water on Jupiter. Because this massive gas giant holds more than double the combined mass of all the other planets in our solar system, even small fractions of water on such a massive planet would amount to a significant quantity, far exceeding the amount of water found on Earth. Water in the gas giant's atmosphere is also the reason why Jupiter, just like Earth, has its own mesmerizing displays of lightning 100 times brighter than terrestrial lightning and peculiar hailstones. Lightning has been detected in the planet's water clouds in the past, where water droplets collide with electrically charged ice crystals. But the Juno spacecraft has also spotted dim lightning at higher altitudes in the atmosphere, where the temperatures drop to approximately -87 degrees Celsius, too frigid for water to exist in its liquid state. So how does lightning happen under such conditions? The answer to the mystery lies in ammonia, a remarkable component in Jupiter's atmosphere that serves as a natural antifreeze. In the upper atmosphere, water ice crystals combine with ammonia vapors and melt. These water-ammonia droplets then collide with additional ice crystals from below, creating an electrical charge that generates lightning. Below the ammonia ice clouds, the ammonia water droplets undergo continuous growth until they become too heavy to remain suspended in the air and resemble large hailstones like we have on Earth. Scientists believe that these mushball-like objects descend deeper into Jupiter's atmosphere. But now, let's travel even deeper into Jupiter's innermost layers. Previously, it was believed that our solar system's giant worlds all have a rocky core. This was the accepted theory for a very long time, but recently, scientists have started to doubt this theory. Using Juno's orbit data, scientists are still studying how matter is distributed inside Jupiter, and recent discoveries have unveiled an unexpected mystery lurking within the gas giant's core. Jupiter's core has extremely high pressures, much greater than on Earth, and temperatures as hot as 20,000 degrees Celsius. To understand these conditions, scientists use powerful lasers to compress samples and mimic the planet's pressures in a laboratory. The Center for Matter of Atomic Pressures at the University of Rochester is at the forefront of this research. The density of materials in Jupiter's core depends on their composition and physical properties. And just recently, scientists have discovered that Jupiter's core is not as compact as they thought it was. Deep within its inner regions, only 18% of the material is rocky. Jupiter is predominantly made up of hydrogen, accounting for about 90% of its composition, along with roughly 10% helium and trace amounts of other elements. In the outer layers of this gas giant, hydrogen exists as a colorless and transparent gas, in the same form as it exists here on our planet. As you descend deeper into Jupiter, the increasing atmospheric pressure transforms hydrogen into a bizarre, dense fluid that conducts like a metal. So what is this substance? Approximately 10% of the way towards Jupiter's core, along its radius, the immense volume of hydrogen gas that forms the planet's atmosphere becomes compressed into a unique form known as liquid metal hydrogen. Liquid metallic hydrogen possesses properties similar to water, with low viscosity, excellent electrical conductivity, and efficient thermal conduction. Within Jupiter, this abundant substance transforms the planet into one huge generator. On Earth, elements exist as solids, liquids, or gases, depending on temperature and pressure. While hydrogen is typically a gas on our planet, it can be compressed and cooled artificially to become a liquid or solid. However, even in these states, hydrogen retains its non-metallic nature, poorly conducting heat and electricity. In contrast, metals excel at conducting heat and electricity due to their atom arrangement. Deep within the gas giant of our solar system, hydrogen undergoes extreme temperature and pressure, which allows for peculiar states including liquid metallic hydrogen. Hydrogen atoms under these conditions shed their electrons, resulting in a mix of free-floating hydrogen nuclei and electrons. This electron mobility resembles metal behavior. There's a theory that Jupiter's core might be filled with vast oceans of this substance, and based on previous estimations of the Jovian core's mass, it could be 12 to 45 times more massive than our planet. A 40,000 kilometer deep layer of liquid metallic hydrogen, combined with Jupiter's rapid rotation of about 10 hours, generates a colossal magnetic field that spans an astonishing distance of 725 million kilometers. This magnetic field stands as the largest in our solar system, and it contains mysteries of its own. Exploring regions more than 320 kilometers down into Jupiter's atmosphere, scientists have identified a newfound area known as the Great Blue Spot, not to be confused with Jupiter's Great Red Eye Storm. Researchers knew that the Jovian magnetic field was complex, but they had no idea just how weird it was. And it has something to do with the Great Blue Spot. The Jovian magnetic field is 20,000 times stronger than the Earth's magnetic field. But now, scientists have discovered that its strength is volatile. Unlike the Earth's dipolar magnetic field, the gas giant's magnetic field originates from a wide area in the northern hemisphere and re-enters near the South Pole. Researchers have also identified a concentrated region just south of the equator, the Great Blue Spot. Is like a second Jovian South Pole located near the equator. The colossal storm that's raged for centuries is probably caused by the presence of high concentrations of ammonia in the atmosphere. The intensity of the magnetic fields in the Great Blue Spot undergoes fluctuations of up to 1% per year, strengthening and weakening across different regions. By the end of the extended Juno mission in 2025, scientists will have ample evidence to evaluate their hypothesis. As research continues, we're going to encounter new mysteries about the gas giant. Since the Great Blue Spot and the Great Red Spot are located at the same latitude, it's possible the two phenomena are somehow connected. Gas giants are typically characterized by their high temperatures, especially in their upper atmospheres. In our solar system, there are two such giants, Saturn and Jupiter. However, Jupiter doesn't have a consistently high temperature throughout its entire structure. The solar system's largest planet is mostly known for its massive storm, twice the size of Earth, the Great Red Spot. But the gas giant has other spots too. The Great Cold Spot is nearly as large, and scientists have been observing this phenomenon for years now. At its largest, the spot is approximately 12,000 by 24,000 kilometers across. But unlike the famous red spot, this intriguing atmospheric feature stands out as a region of significantly colder temperatures compared to its surroundings, about 200 degrees cooler than the surrounding atmosphere. The Great Cold Spot is volatile, disappearing and reappearing from time to time. Scientists have discovered that this phenomenon's recurrence is triggered by the planet's auroras. Because of this correlation, the spot's age is about the same as the age of Jupiter's polar lights, which is in thousands of years. Jupiter's auroras, similar to Earth's, are produced by charged particles interacting with the planet's atmosphere near the poles. However, the gas giant's polar lights are more stable and intense, as they receive particles from both its moons and the Sun. New findings indicate that these auroras transfer energy to Jupiter's atmosphere, creating a temperature difference between the upper and lower regions. This temperature contrast leads to the formation of a swirling vortex, resulting in a cooler patch that is distinct from the aurora and its surroundings. Earth also experiences similar effects. However, the combination of factors like Jupiter's rotation that helps retain heat in specific areas and the varying nature of these events makes the occurrence of polar lights on our planet less consistent. Another discovery made about the gas giant was that, contrary to common belief, Jupiter doesn't actually orbit the Sun. The center of gravity between Jupiter and the Sun does not reside within the Sun itself, but instead exists at a specific point just above the Sun's surface. In space, where a smaller object seemingly orbits a larger one, both objects actually orbit around a combined center of gravity. Consider Earth and the Sun, for instance. In this case, the center of gravity is so close to the center of the larger object that its impact is hardly noticeable. The larger object appears motionless, while the smaller object traces a seemingly perfect circular path around it. The same happens when the International Space Station orbits the Earth. Both the Earth and the ISS orbit around their shared center of gravity, even though our planet seems to be completely stationary, while the ISS appears to orbit the Earth in perfect circles. This principle generally holds true for most planets in our solar system. Even Saturn has negligible influence on the Sun's position in space. However, as the difference in mass between the two objects decreases, everything changes. In the case of Jupiter, its immense size causes the center of mass, known as the barycenter, to exist 1.07 solar radii away from the Sun's center, approximately 7% of a solar radius above the Sun's surface. This means that both the Sun and Jupiter orbit around this particular point in space. Our ancestors knew the monstrous size of Jupiter. The gas giant's mass is 2.5 times the total mass of all the other planets in the solar system, and 317.8 times the mass of the Earth. Jupiter's volume is 1,300 times larger than our planet's. But today, we've advanced technologies that help us learn more about the gas giant than just size and mass. And astronomers pay a lot of attention to the study of Jupiter, as our planet's future depends on it. The latest data we have shows that, right now, something strange is happening with the planet. Jupiter is considered the super vacuum cleaner of the solar system by astronomers because of its immense gravity well and where it orbits in the inner solar system. The gas giant has taken some huge impacts from asteroids that could have hit Earth in the past. like Shoemaker-Levy 9, which slammed into Jupiter as it broke into pieces in 1994. But the planet's gravity isn't always protecting us. Along with Venus, it affects the Earth's climate. Every 405,000 years, gravitational fluctuations between Earth, Venus, and Jupiter bring us abnormally cold winters and hot summers. Droughts become severe and rains cause floods. Researchers say we're now somewhere in the middle of this cycle, and if something goes wrong on Jupiter, it could affect Earth in a big way. So what is the weird thing going on with Jupiter? For once, its most famous storm seems to be shrinking, and we have no idea how that will affect the planet. The Great Red Spot is a huge anticyclonic storm on Jupiter. The largest storms on Earth are more than 1,600 kilometers across, with winds reaching up to 320 kilometers per hour. But these hurricanes pale in comparison with the Great Red Spot anticyclone, which is about 16,000 kilometers in diameter. The gigantic storm is circling Jupiter at 650 kilometers per hour. Astronomers discovered the Great Red Spot in the 17th century, and scientists still study this phenomenon. The distinctive color of Jupiter's Great Red Spot has been a mystery for a long time. Some scientists believe the storm is colored by complex organic compounds. The whirlwind lifts them from the inside of the planet into the upper layers of the atmosphere. Others think the rusty color comes from sunlight splitting up different chemicals in the anticyclone's upper atmosphere. If so, the storm isn't actually very red at all, and what we might see is just a sort of sunburn at the top of it. Another interesting question is why the anticyclone lasts so long. Scientists have suggested it's because of Jupiter's composition, which is mostly hydrogen and helium. The gas giant has no solid surface to frictionally weaken the storm. On Earth, friction reduces the wind speed near the surface. This slows down storms. But other planets in our solar system aren't like the Earth either. Saturn, for example, isn't rocky, and storms there don't last this long. The biggest storm on Saturn, the Great White Spot, covers several thousand kilometers. You can see it through a telescope as a white oval. This spot appears every 30 years and then vanishes without any trace. The Big Dark Spot on Neptune, which was discovered in 1989, was also proved to be short-lived. The wind around the storm reached supersonic speeds of up to 2,400 kilometers per hour. The large dark spot was constantly changing its shape and size. With that much activity, the storm was clearly not going to subside, and yet, in 1994, it disappeared. But let's get back to the Great Red Spot. The Juno spacecraft passed over the anticyclone twice in 2019. It took images of the storm to help determine its nature. Using Juno's data, scientists compiled a three-dimensional model of Jupiter. It showed that the Great Red Spot extends much deeper than previously thought. On Earth, a storm of this size would rise above the International Space Station. Researchers say that, taken from above, the cyclone looks like a huge pancake, but a really thick one, going 500 kilometers deep into the clouds of Jupiter. This is 50 to 100 times deeper than the Earth's oceans. The storm is powered by atmospheric jets that go far deeper, about 3,000 kilometers. Scientists are still trying to unravel the mechanism behind how these jets move. So far, there's only one clue from the spacecraft data. Atmospheric ammonia gas is moving up and down in the jets. This is very different from the way things happen on Earth. On our planet, atmospheric phenomena are largely driven by water, clouds, condensation, and sunlight. This is what we'd probably see inside the Great Red Spot if we could get there. The gravity there would be intense. The Juno spacecraft passing over the Great Red Spot was like driving a car on a road full of potholes. Radio waves reaching Earth were slightly compressed and stretched. Thanks to this effect, scientists picked up tiny tremors, 0.01 millimeters per second, and were able to calculate the gravity inside the storm. It turned out to be so strong, as if a mysterious planet was hiding at the bottom of the anticyclone. But of course, scientists didn't find any planet there, only a gas surface. Meanwhile, new measurements from the Hubble Space Telescope show that the storm has changed its form from oval to round and shrunk considerably. Previously, 3 Earths would fit inside the monstrous storm, but now only 1. Look at these Hubble telescope images from 1995, 2009, and 2014. You can see how the Great Red Spot has shrunk in just 19 years. So why is the storm on Jupiter shrinking? And do we have anything to worry about if the storm disappears? According to researchers, something in the planet's atmosphere is killing the storm. An unknown force is tearing apart the Great Red Spot. In May 2017, the Gemini North Telescope spotted a small hook-shaped cloud on the west side of the storm, and something else that looked like a wave peeling off its eastern side. The Juno spacecraft also took an image of red flakes flying away from the spot. Researchers confirmed that formations of various shapes actually detach from the Great Red Spot and scatter into space. These huge chunks, up to 100,000 kilometers in size, are about the size of Portugal or Iceland. Computer models show this is a very natural phenomenon for Jupiter's complex atmosphere. It may happen due to the convergence of the Great Red Spot and smaller storms. On Jupiter, anticyclones are attracted to other anticyclones, and opposites, such as cyclones and anticyclones, repel. The merging of anticyclones is a long process. In the beginning, a smaller storm becomes a small bulge closely adjacent to the larger hurricane. Then, the larger storm merges with the smaller one. But when anticyclones meet with cyclones, something different happens. A clockwise rotation of an anticyclone and a counterclockwise rotation of a cyclone first bring them to an abrupt halt. Then the motion resumes with an unimaginable force and scatters the storms in different directions. A small anticyclone wouldn't merge with the Great Red Spot, but shatter into pieces instead. And these pieces of different shapes would then separate from the storm. This is what astronomers believe they are observing. And the Great Red Spot is still shrinking. According to scientists' calculations, it could disappear in about 20 years. Jupiter is unlikely to be affected, but there may be some irreversible processes that the storm was preventing. Only time will tell what will happen when the storm completely disappears. Based on data from the Hubble telescope, the average wind speed around the red spot increased by 8% from 2009 to 2020. And this means the anticyclone isn't losing activity and may increase in size again. Or it could be replaced by another storm. In 2000, 3 small oval white vortexes on the planet merged together. And at the end of 2005, a new hurricane turned red. Astronomers called it the Small Red Spot. In 2006, the Small Red Spot came into contact with the Great Red Spot. Because this was a slight collision, it didn't have any significant effect on the two whirlwinds. But how will the two storms get along in the future? To sort things out, NASA's mission Juno was extended for 5 years in 2021. The spacecraft will monitor mysterious polar cyclones, the planet's magnetosphere, and its incredible red storms. Jupiter continues to be studied by the Hubble and Webb Space Telescopes, as well as many ground-based observatories.
But spacecraft continue to explore other worlds across the solar system as well. And some of the most remarkable images in recent years have come from Neptune.
On the 25th of August, 1989, humanity brushed the unknown. On that day, the Voyager 2 probe rushed past Neptune 2.7 billion miles from home. It only had one chance, one instant to take a picture. And it delivered an image of a perfect, calm azure sphere. For many years, we believed in that image, but those images were a mistake. Recently, scientists discovered an anomaly in the data that had previously gone unnoticed. And when the James Webb Space Telescope turned its optics towards the 8th planet, the truth was revealed. Behind the calm blue facade lies something inexplicable. If you tried to descend into its atmosphere, you wouldn't find any surface to stand on. You would fall through an endless storm where the temperature drops in defiance of all laws of physics. And right now, as you watch this video, there's something strange happening on Neptune. Passing just 3,000 miles above Neptune's cloud layer, Voyager 2 captured the first high-quality images of Neptune in history. Sometime later, they reached NASA specialists. It was met with excitement, but it was soon followed by mixed feelings. After the riot of colors on Jupiter and the magnificent rings of Saturn, Neptune looked too calm, a smooth blue pearl. It seemed like a world where time had stopped, but that calm only existed in the pictures. As soon as scientists made sense of the data, a completely different world opened before their eyes. This bright blue shell was hiding a true hell raging underneath. Sensors recorded winds that are hard to imagine. Gas streams racing at speeds exceeding 1,300 miles per hour. That's supersonic. The most destructive Category 5 hurricane on Earth is a light breeze compared to ordinary winds on Neptune. Moreover, there's a strange mechanic at work here. The winds blow against the rotation of the planet itself. This creates monstrous friction and turbulence, turning the atmosphere into a global meat grinder. Just imagine, the planet rotates around its axis, but its gaseous atmosphere rushes in the opposite direction at terrifying speed. Even with the most advanced spacesuit, an astronaut would survive for just a few seconds. There would be nothing left of them. For 3 decades, Neptune remained a mystery to us, limited by the capabilities of Voyager 2's aging equipment. Now, everything is different. Today we have the James Webb Space Telescope. Thanks to its advanced instruments, it's shown this world as we've never seen it before. This image was taken in the infrared range, where the planet no longer looks blue. It appears as a darkened sphere surrounded by glowing halos. This is pure physics. Methane in the atmosphere absorbs sunlight so greedily that the planet itself looks almost devoid of reflection. Against this gloomy background, JWST detected a distinct bright band along the equator, a thermal imprint of deep circulation. This phenomenon can be called the planet's energy belt, where heat rises from the deepest layers, powering the entire atmosphere. It's precisely this relentless energy whose thermal traces were spotted by JWST that gives rise to the most frightening anomalies in the atmosphere. Back in 1989, Voyager 2 recorded one of them, the Great Dark Spot. A giant anticyclone the size of Earth looked like a deep wound on the body of a giant. But unlike Jupiter's Great Red Spot, storms on Neptune practically act like ghosts. They appear, destroy everything around them, and disappear without a trace within a couple of years, only to emerge in a new place. This discovery left physicists at a dead end. Neptune is 2.8 billion miles from the Sun, which means it receives 900 times less light than Earth. The temperatures here are extremely low, minus 220 degrees Celsius. Where does the power for supersonic hurricanes come from? The answer is hidden inside. The planet heats itself. There's a powerful heat source hidden deep within Neptune. The planet radiates 2.6 times more energy into space than it receives from the Sun. This is not just an icy rock wrapped in gas. It's a giant thermal machine operating on the edge of the solar system. And what happens in the depths of this machine under incredible pressure gives rise to the phenomena that on Earth would be considered science fiction. To find the source of this anomalous energy, we need to descend to a place where no probe created by humans could survive. There's no clear boundary between sky and surface. As you descend, the gas simply becomes thicker, denser, and hotter, until imperceptibly it turns into a strange, super-dense liquid. Now we enter the planet's mantle, an ocean of boiling water, ammonia, and methane. Imagine if an unfortunate astronaut found themselves here. At a depth of about 4,000 miles, the concept of survival becomes meaningless. Here, the pressure is millions of times higher than on Earth. This is like placing a massive ocean liner on your chest. Even in the strongest spacesuit they may theoretically make in the future, you wouldn't simply be crushed, you would be compressed into a dot in a fraction of a second. And the temperature of 4,000 degrees Celsius would vaporize the remains faster than your brain could register a pain signal. Here, at depths ruled by extreme pressure and temperatures approaching that of the Sun's surface, something truly incredible happens. For a long time, this existed only as a theory on paper. But recently, scientists at the SLAC National Accelerator Laboratory in California managed to recreate these lethal conditions in their laboratories. They proved something incredible. Under this monstrous pressure, carbon in the atmosphere is compressed so much that it crystallizes. In other words, in the absolute darkness of Neptune's depths, it's raining. But these are not raindrops made of water. These are diamonds. Millions of tons of precious gemstones, some maybe the size of a pea, others enormous, like icebergs. They slowly sink through the liquid mantle, moving toward the core over thousands of years. That's where this thermal energy is born. As they fall, these diamond masses create colossal friction. This process generates heat that rises upward and speeds the atmosphere up to those very supersonic speeds. The planet is literally recycling itself, creating treasures and chaos at the same time. This raging ocean gives rise to another anomaly, one that can be called a broken magnetic field. Its axis is shifted from the planet's center by thousands of miles. On Earth, the needle of a compass always seeks north. Meanwhile, on Neptune, it would simply dart from side to side, trying to find orientation in a space where the poles are not where they should be. This magnetic chaos creates the strangest auroras in the solar system. On Earth, we're used to seeing majestic crowns of light strictly over the poles. But on Neptune, auroras are homeless ghosts. Since the magnetic poles are shifted and tilted, the auroras may flare up anywhere. The sky over the equator can suddenly explode with ghostly light, only to vanish and reappear on the other side of the planet. These are not smooth ribbons of light, but sharp, chaotic flashes. The planet's magnetosphere practically tumbles under the blows of the solar wind, forcing the atmosphere to glow at random points. Neptune is a world that has lost its internal compass, and the sky is the best proof of that. But this was not the final stage in the study of this distant planet. In 2022, the James Webb Space Telescope directed its scientific instruments toward the bright blue giant to analyze its thermal structure. The obtained data indicated that something inexplicable was happening in its atmosphere. Neptune was showing activity in the upper layers of the atmosphere that defies all logic. On the coldest planet in the system, there were flares that usually mean only one thing: summer has begun. A summer that, by all laws of physics, is impossible. The unique cameras of the James Webb Telescope are tuned to the deep infrared range, a spectrum in which the observed object can be seen in a completely new form. Under the gaze of these cameras, Neptune stopped being a cold blue disk. It turned into a pulsating thermal anomaly. What appeared before the scientists' eyes looked more like an anatomical cross-section of a complex machine, rather than a frozen world on the outskirts of our solar system. The first thing that surprised the scientists was the rings. Since Voyager 2, they had been considered dim, almost vanishing threads of dust. But looking through the lens of James Webb, they flared up like bright neon halos. These ghostly rings, made of icy debris and organic material, look so active in infrared light that it seems as if they're connected to a powerful power source. The telescope recorded even the finest dust bands, linking the outer rings with the upper layers of the atmosphere, essentially acting as energy bridges whose existence had previously been only a bold theory. But when the excitement over the image was followed by the analysis of the temperature data, a wave of alarm swept through NASA headquarters. Neptune is a planet of extremely slow cycles. What we may regard as Neptune's summer season lasts 40 Earth years. According to all laws of thermodynamics, a smooth and predictable rise in temperature should be observed in the southern hemisphere, but reality turned out to be different. Over the past 15 years, Neptune's stratosphere unexpectedly cooled by 8 degrees Celsius. At the height of summer, the planet began to cool rapidly. This is a global thermal failure on a planetary scale that defies the logic of solar heating. But while the entire planet was sinking into an anomalous cold, its south pole suddenly flared up. In just a couple of years, the temperature in that area jumped up by 11 degrees Celsius. The Earth equivalent of that would be if an ice age started across our entire planet all at once, yet in the center of Antarctica an ocean was suddenly boiling. This phenomenon was called false summer. At a distance of 2.8 billion miles from the Sun, Neptune behaves like an unstable, overheated reactor. This thermal explosion gives rise to giant clouds of methane ice. In JWST's images, they look like blinding scars hovering above the main mass of gas. They reflect the remnants of light with such force that they partially overshadow the planet itself. But while the scientists' instruments record the strange climate behavior, the finale of a cosmic catastrophe is unfolding in the shadow of the pulsating giant. In this image, you may have noticed a bright point near Neptune that shines brighter than the planet itself. No, this is not a distant star. This is Triton, Neptune's moon, and at the same time, its captive, stolen by Neptune from the Kuiper Belt billions of years ago. This hostage moves against all the laws of the system, and its time is running out. Neptune does not simply hold it close. Slowly, with sadistic precision, the giant pulls the satellite towards itself, and their collision will become one of the most destructive events to ever occur on the edge of the solar system. Billions of years ago, Triton was a free world. It was a dwarf planet traveling in tandem with another icy object in the deep abyss of the Kuiper Belt, but their route turned out to be a fatal mistake. At some point, they came too close to Neptune's gravitational field. That's when a cosmic robbery took place. Neptune, whose mass exceeds Earth's 17-fold, simply flung Triton's partner into open space and chained Triton to its orbit. This was not a gentle takeover. It was a collision of orders. Massive Triton burst into Neptune's system, triggering a gravitational chaos. The planet's original moons started to crash into each other, turning into debris or being cast out. When this chaos ended, Triton became Neptune's largest moon, but it's been paying a price for its dominance ever since. Triton's orbit is an anomaly. It moves against the flow. It's the only large moon in our system with retrograde rotation. Imagine driving down a highway against traffic. That's what Triton does every second of every day. And this wrong motion is its own death sentence. Neptune's gravity works like an invisible but merciless brake. It constantly steals this moon's velocity. Triton does not simply orbit the planet, it is falling toward it, along a long, fading spiral. Every year, it gets a few inches closer to its final catastrophe. If you stood on Triton's surface, Neptune would look like a giant icy sphere, occupying a huge part of the horizon. And in that silence, you would experience what real cold feels like, minus 235 degrees Celsius. This is not just a bit of frost. This is a temperature at which nitrogen in the air turns into solid pink ice. Here, ordinary water is harder than steel, and metals become fragile like glass. But Triton is not just some dead lump. Neptune's gravity constantly compresses and stretches its interior like a piece of Play-Doh. This friction creates heat that breaks out through cryovolcanoes. In these frames captured by Voyager 2, you can clearly see the movement of a black column of gas stretching above the moon's surface. Instead of fire, these cryovolcanoes expel a mixture of liquid nitrogen and methane. In this image, the height of the plumes reaches 5 miles. For reference, that's almost the height of Everest. Black dust settles on the pink snows, creating a bizarre landscape that scientists call cantaloupe terrain, because of its strange, wrinkled texture. Triton is constantly shedding its skin, trying to survive under the unbearable pressure of its host. In images from the James Webb Space Telescope, Triton shines brighter than the planet itself. Its icy shell works like a giant mirror, reflecting 70% of sunlight. But behind this brilliance lies an inevitable finale. In about 3.5 billion years, Triton will cross the point of no return. It will come so close to Neptune that the planet's gravity will become stronger than the forces holding the moon together. It will lead to an instant disintegration. Triton will simply explode into billions of fragments. Huge blocks of ice will spread along the orbit, creating rings around Neptune. Scientists theorize that these rings will be even brighter and more massive than Saturn's. That will be a majestic farewell gift from the captured wanderer. Eventually, these rings will also disappear, descending into the atmosphere. Neptune will once again become what it was at the very beginning, a lonely azure object on the outskirts of the solar system. We began this journey viewing it as a calm blue planet, but now we know that Neptune is a world of supersonic hurricanes, diamond rain, and temperature anomalies. A world that lives by its own rules in the darkness of space. But what if we told you that for decades we've classified Neptune improperly? Neptune and its twin Uranus are not gas giants. Today, scientists classify these two planets as ice giants, and this planetary classification is nothing like ordinary gas giants. Neptune and Uranus are icy fortresses with physics that seems impossible. And if we were wrong about their very nature, then the scale of what is hidden beneath their clouds may turn out to be far more than in any of our theories. Studying Uranus and Neptune, scientists are coming to astonishing discoveries. These worlds turned out to be so exotic that we should consider ourselves truly lucky to have such fascinating neighbors in our system. Or are we unlucky? What if Neptune will be the planet that ends the existence of all life on Earth? A single external influence, and this giant could trigger a chain reaction that will turn our solar system into real chaos. There's 4 gas giants out there in our solar system, but unlike Jupiter and Saturn, Uranus and Neptune are rich in water. Most of that water is in the form of ice, and now new studies found there may also be oceans under their icy layers. But that's not all. Researchers now say these oceans could be rich in magnesium, but these oceans might be made of something else entirely, and we'll get to that soon. We need to mention that even though Uranus and Neptune are considered gas planets, they're also called ice giants because of their rocky, icy cores, which are much larger than the amount of gas they hold. But some strange things have been discovered lately, and researchers have been trying to figure out what is happening on the surface of these 2 ice giants. Not only that, but some have wondered what it might be like if you tried to land on any so-called surface of Neptune and Uranus. You may have also heard that it could actually rain diamonds on these planets, and now some researchers believe that both Uranus and Neptune could have oceans of liquid diamonds. Now that sounds wild. But how is this possible? Keep that in mind, because we're going to get to that in a couple of minutes. But first, let's take a look at each of these planets, and we'll tell you the most incredible things that have been discovered up to now. You have to admit that Uranus is a bit of a sad and lonely world, one that's tired of being the butt of many bad jokes, including that one. However, its name is actually a reference to the Greek god of the sky. This freezing world was the first planet ever discovered using a telescope in 1781 by William Herschel, and is about 2.9 billion kilometers from the Sun. Voyager 2 got as close as 80,000 kilometers from the planet and captured only a handful of images. But those images had astronomers thinking it's possible that something really big crashed into Uranus in the early days of the solar system, not once, but twice. The result of these 2 big impacts left the planet rotating on its side. This means it's orbiting the Sun like a rolling ball, which, by the way, takes 84 Earth years to go around once. Uranus has 27 moons, and they could have formed from these big collisions that put the planet on its side. Also, its magnetic north and south are way different from its polar north and south. Because of this, there are some really bizarre seasonal effects. Imagine a planet that has its south pole pointing at the Sun, while the north pole is shrouded in complete darkness for 21 years. In 2011, telescopes showed something strange happening on the planet. A big fuzzy white spot appeared on its frigid blue cloud tops, and astronomers claimed it was a giant methane storm. In fact, some of these storms have been spotted by the Hubble telescope. Huge storms half or more the size of the entire USA. The average temperature in the methane and ammonia clouds is minus 128 degrees Celsius. Winds on the planet can reach up to 144 kilometers per hour. And by the way, Saturn isn't the only planet in the solar system to have rings around it. Uranus has 2 sets of rings, both orbiting above its equator. But its icy twin Neptune is even farther away from the Sun, some 4.5 billion kilometers away, and it takes 165 years to orbit the Sun. Voyager 2 was able to get as close as 4,828 kilometers to Neptune, which appears to be made up mostly of ices and rock, and could possibly have a rock-ice core about 1.2 times the size of the Earth, and around 10 times the Earth's mass. Its atmosphere is made up of 3/4 hydrogen and 1/4 helium, with a small amount of methane that produces clouds. The bluish color of the planet is from light scattering and red wavelength absorption by the methane in its atmosphere. Like Jupiter's giant iconic red eye, Neptune also has a huge dark vortex, an anticyclonic storm called the Great Dark Spot that's 11,000 kilometers across, almost as big as the Earth, and it's racing across Neptune at 1,100 kilometers per hour. But that's not all. In fact, Neptune has the most ferocious and fastest planetary winds in the entire solar system, reaching 2,000 kilometers per hour. Definitely no place for a holiday. The energy for those high-speed winds is not coming from the Sun, but what might actually be happening closer to the core of the planet. In fact, Neptune appears to have some kind of internal heat source and radiates twice as much energy as it gets from the Sun. And even though it's farther away from the Sun than Uranus, it's a bit warmer, thanks to Neptune's atmosphere, which is probably holding in heat from its hot core. Now, both of these planets have unstable and strange magnetic fields that are strongly tilted relative to each planet's rotation axis, and are significantly offset from the physical center of each planet. It's been a long mystery for some time now, and no one's sure why these magnetic fields act so strange. The magnetic field on Neptune is 27 times more powerful than that of the Earth, while Uranus only has a magnetic field 1/3 as strong as the Earth, and we'll explain in a minute what scientists think is causing the magnetic fields to act strange. Even though it might seem really cold on both of these worlds, and the magnetic fields are bizarre, intense heat and pressure thousands of kilometers below the surface of each planet may tell a different story. The atmospheres of both planets are primarily made up of hydrogen and helium, with small amounts of methane. Below these atmospheric layers is a super hot, super dense fluid of icy materials like water, methane, and ammonia that wrap around the planet's core. Because of this, astronomers studying these 2 ice giants have come to the conclusion that it could be raining diamonds closer to the surface of each planet. This is possible because deep inside both these ice giants, pressure and heat builds until gaseous hydrogen turns into liquid metallic hydrogen. Methane in the atmosphere decomposes, and as the bonds holding methane's 4 hydrogen atoms dissolve, the carbon atoms left over bind to one another under extreme pressure to form diamonds. At its core, Neptune reaches temperatures of up to 7,273 Kelvin, which is comparable to the Sun, while the core of Uranus heats up to 9,000 degrees Fahrenheit. Yes, it could actually be raining diamonds closer to each planet's core. But not only that, it's also possible that there are oceans of liquid diamonds beneath the surface of the 2 ice giants. Research was done by taking detailed measurements of the melting point of diamond. When diamond is melted, it behaves like water during freezing and melting, with solid forms floating atop liquid forms. Obviously, diamond is a very hard material, making it really hard to melt. And measuring the melting point of a diamond is also very difficult, because when it's heated to very high temperatures, diamond changes to graphite. But it's diamond that turns into a liquid, not graphite. So what scientists did to get around this problem is expose the diamond to extremely high pressures by blasting it with lasers. Diamond is liquefied at pressures 40 million times greater than found at Earth's sea level. When the pressure is lowered to 11 million times greater than the Earth's sea level, chunks of diamond start to appear. But something happened that scientists didn't expect. The chunks of diamond didn't sink, but floated on top of the liquid diamond layer, creating diamond icebergs. These are the same ultra-high temperatures and ultra-high pressures found on both Uranus and Neptune. Both planets are estimated to be made up of 10% carbon, so a large ocean of liquid diamond could deflect or tilt the magnetic field out of alignment with the rotation of the planet, which could explain the strange magnetic field behavior. Is it possible that both planets rain diamonds and have vast oceans of liquid diamond? Only by sending a spacecraft there will we find out. Now researchers and scientists are trying to get NASA to send a spacecraft to these two worlds in order to study them. But the planets will be closest to the Earth soon, and astronomers say that a spacecraft would need to be launched by 2030 in order to take advantage of Jupiter's gravity and slingshot the spacecraft towards these ice giants to arrive in the mid-2040s. In April 2021, astronomers spotted X-rays coming from Uranus using the Chandra X-ray Observatory. This revealed some unknown dimension of the colorful ice planet. This means that X-ray emissions have been detected on every planet in our solar system now, except for Neptune. In case you're wondering, there are 3 ways a planet can produce X-rays: fluorescence, scattering of solar X-rays, and emissions from auroras. Uranus is scattering the sun's X-rays, and X-rays are also being created by energetic electrons or protons, which collide with the rings, causing them to glow in X-rays. It's pretty much the same thing that causes Earth's beautiful and amazing auroras. We may soon know a lot more about these 2 mysterious planets in the future, so make sure to stay tuned here to stay up to date. Thanks for watching.